When you decide to move to the cloud, one of the first things you have to do is give them your credit card. That's because they're giving you access to a massive network of computers worth billions upon billions of dollars. When you write inefficient code on your own computer, it's usually not a big deal. The CPU fan might spin a little faster, or things might run slower when you run out of RAM. But in the cloud, it's a whole different ballgame. That recursive function you wrote can now scale infinitely around the globe, blowing up CPU cores and melting solid-state drives in the process. And someone is going to have to pay for that mess. In today's video, we'll look at a real-life story about how a startup, just days away from launch, racked up a $72,000 Google Cloud bill.
And it's gone. Didn't do too well, it's gone. Poof.
We'll find out how that's even possible, but more importantly, we'll look at ways to prevent something like that from happening to you. If you're new here, like and subscribe, then let's get right into it. Imagine spending months pouring blood, sweat, and tears into your startup. You're just days away from the big launch, doing some final testing here and there. Your product is ready to go. You just need to scrape some data from the web to enrich the user experience. You throw together some ad hoc code to get the job done, Dockerize it, then deploy it to a serverless platform like Google Cloud Run. It only needs to run for a few hours, so you deploy it, then call it a night. You wake up to a couple of interesting emails. Our Firebase project was upgraded from the free plan to the pay-as-you-go plan. We must have enabled an API that requires billing, which automatically upgraded the plan. Not to worry, we already have a budget alert in place. Oh no, the next email tells us our $7 budget has been exceeded. The third email tells us our credit card was declined. I wonder why that would be. Let's open the billing panel in Google Cloud.
No! God, please, no! No!
A bill of over $5,000 in just a few hours. It has to be a mistake. Let's refresh the page and pray.
No! No!
5 minutes later, the bill's at $15,000. After 20 minutes, $25,000. The final bill settled up after about 2 hours, just short of $72,000, increasing your startup's burn rate by about $600 per minute.
No!
If you're a bootstrap startup, you might as well make it $10 million. To make matters even worse, this company had multiple products, with multiple Google Cloud projects to manage them. Because things got out of control so quickly, they had to disable all of their projects. And that's the story of how one little recursive function took down an entire business.
I declare bankruptcy!
Luckily, the story doesn't end there. The company immediately contacted Google Cloud to make them aware of the issue and let them know that they did not intend to purchase this much computing power. After 10 days of deliberation, Google did the not evil thing and credited the entire $72,000 bill. That must have been a huge relief for the company and was a big win for independent developers around the world. But keep in mind, there's no guarantee you'll get the same kind of credit when you rack up a massive bill. The best strategy is to not rack up a massive bill in the first place. However, that's easier said than done. I've actually racked up 2 massive bills myself. One time, I accidentally exposed my AWS API key in a public Git repo. A few months later, I had a $5,000 AWS bill because a hacker scraped the key and then used it to spin up a bunch of compute instances. Luckily, they gave me a credit for my bill as well. It is very reassuring that these big cloud companies would rather keep you as a long-term customer than try to bankrupt you over an honest mistake. But a bill of $72,000 is crazy. I've never seen a bill get that high that quickly. And we should all be thanking Announce today for sharing that story with us. Check out their web app for a great example of Angular and Firebase in the wild. Then let's dive into the technical reasons for the massive bill, and more importantly, ways to avoid it yourself. Tip number 1, set up a budget alert, even if you're on the free plan of something or in the free tier. Once you deploy code to the cloud, there are different ways you might exceed the free tier without knowing it. It's not common, but it's still always a good practice to have a budget alert set on your account globally. The company did this right by setting a budget for $7. The problem in this case, though, was that the cost increased so quickly. An alert will only send you an email. It doesn't actually shut down anything when the budget has been exceeded.
Right. Yeah,
it's actually kind of crazy that there's not an easy way to shut down services when the budget has been exceeded. That's been a major criticism of the cloud for as long as I can remember. However, there may be hope. In October 2020, AWS released a new feature called Budget Actions, where you can define an action based on a budget threshold, like shutting down a server once you've spent too much money. In addition, on Google Cloud, you can listen to budget events with PubSub, and that means you can write a little bit of code to create a kill switch that disables billing if the budget is exceeded. Now let's move on to the next tip. Do not create infinite loops in the cloud. Do not create infinite loops in the cloud. Do not create infinite loops in the cloud. When it comes to serverless computing, everything is event-based. Some kind of event happens in the cloud, like an upload to a storage bucket, which triggers a cloud function for additional back-end work. It's really easy to shoot yourself in the foot here, though, if your function leads to the same event that triggered it in the first place. For example, a cloud function is triggered by a storage upload, Then you upload a file to the storage bucket again in the function, thus triggering another function, and again and again and forever until the end of time, or until your bank account is empty. That's what we call an infinite loop, and it's probably the number one cause for runaway cost unexpectedly, especially if your infrastructure is configured to handle huge workloads. That brings me to tip number 3. Don't configure things to scale when you're just messing around. Our startup used a service called Cloud Run, which are serverless functions that support Docker containers. By default, Cloud Run will scale to a max of 1,000 instances. Now, if we take a look at the architecture for the web scraper, you'll notice it starts with a manual request to the Cloud Run endpoint. Each run scrapes the URL and saves the results in Firestore. Then it takes all the links it found in a scraped web page and triggers another Cloud Run to process them. If we look at this as pseudocode, what we have here is a recursive function, but a recursive function with no stopping point, which leads to Stack Overflow, or in this case, Cloud Overflow, which is a brand new word that I just coined. Because the infrastructure was set up to scale, it resulted in 116 billion reads to the database and 33 million writes, along with 16,000 hours of Cloud Run compute time. The moral of the story is to understand how different services scale and configure them to not scale if you don't need that functionality. In the case of Cloud Run, if the max instance option was set to 1 instead of 1,000, their bill would have been $72 instead of $72,000. But in production, you likely do want things to scale, and sometimes you won't know how bad an issue is until your app does scale. Which brings me to tip number 4. Consider how algorithm complexity affects your cloud computing usage. A while back, I made a video about how to not get a $30,000 Firebase bill, which was another case study about a company that went viral and a flawed data model caused their bill to accelerate exponentially. Allow me to explain. They built a crowdfunding app, and in the app, they calculate the total amount donated to a crowdfunding cause. They perform the calculation client-side by reading all of the donations from the database for that cause. Now let's imagine you have 5 people who donated to a cause and 100 visitors to that page. That would equal 500 document reads. Now let's imagine you have 100,000 visitors. That'd be about 500,000 reads, which still isn't too bad. But now, let's imagine you have 5,000 donations to a cause. Multiply that by 100K users, and you now have 500 million document reads. Or in other words, at the current traffic level, each new donation adds an additional 100,000 document reads to the total workload. It just doesn't scale well. A better option would have been to aggregate the data on the back end with a cloud function. Rather than calculate the total client side, it can be done on the back end so that each visitor only has to read 1 document instead of 5,000 documents. Now, I realize stories like this are pretty alarming, but Firestore is actually very inexpensive. And because it's so easy to use, you may not realize you're making a bad data modeling choice until it's too late. Using the right data model can go a long way, and you can learn more about that in my data modeling course. But yet another way you might experience runaway costs is by failing to secure your app. And that leads me to tip number 5. Make sure your app is secure. Most importantly, make sure to protect any secret API keys. Like I mentioned earlier, exposing my AWS API key on GitHub allowed a hacker to take full control over my account. But there are many other ways you might fail to secure your infrastructure. When it comes to Firestore, you need to define security rules to define who has access to what in the database. And of course, I have a full course on that as well. Leaving the database open means anybody could read or write to it. Not only does that leave you vulnerable to a data breach, but also to hackers that just want to drive up your costs. The same principle goes for any application that is available on the web. When you have a service that's available on the internet, it means someone can find that URL and exploit it. I'm going to go ahead and wrap things up there. Please make sure to like and subscribe. And if you're building...
It's a great video by Fireship, and he essentially showed how a simple mistake can, increase your cost. I really loved watching this video. It's a great channel. You can search it up on YouTube as well. It's called Fireship. It was a nice video, and then he really showed what are the steps you need to take in order to avoid such mistakes as well. Thank you for watching this video.